Hey everybody, this is Larry. This is me going over weekly contest 204's Q4 number of ways to reorder a way to get same BST. Hit the like button, to subscribe button, join the Discord. This is a tricky problem, but a lot of it is because it requires math. I don't know if it will be a good interview question, but we'll go over the math as much as we can, and some of it will require some knowledge or just maybe some intuition about a binary search tree. So, okay. So the first thing to notice around the ordering of insertion is that, the first number that you insert will always be the root, right? And from that, you could construct a recursive definition of sorts, right? And you know that all the numbers that are, given that, okay, let's say for example, there's 3, right? Given that this is the root, you know that everything that the suffix of it, all the numbers bigger than 3 will be on the right, and then all the numbers that's less than 3 will be on the left. So that's how I define it. That's how I define this recursively. And then how this is, for me, this is a divide and conquer problem of, okay, now given that, what does that mean, right? Well, what that means is that, and separating aside, one thing that I noticed, and some of that just looking at this example, is that you have the interleaving the left and the right, 1, 2, 4, 5. You know that the 1 has to come before the 2 and the 4 has to come up before the 5, but it doesn't matter which, like it could interleave in some way. So then for me, I just had to come up with the formula. And if you have 2 arrays, let's say you have a left array and a right array, and has some length of L or n sub L, let's say, and then this is length of n sub R, right? And that means that, let's say in a really base case, there's L, L, R, R, there's 2 left and 2 rights, and then what are the number of possibilities, right? Well, it could be L, L, R, R, it could be L, R, L, R, L, 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 R, and so forth, right? Dot, dot, dot. So, you get the idea. So how many possibilities are there, right? So this is a common combinatorial thing. I think it's called stars and bars. But yeah, so basically this becomes a stars and bars problem, and let me put up a wiki article here. So this is a link. I'll put it somewhere below. But basically, you could look at either one, the L or the R as bars, and then just separating the stars. But the short answer is this comes out to the length of left plus length of right, this factorial, over length of L factorial, this times n of R factorial. So that's kind of the how you choose this. So that's how you kind of get the formula, which I have here. So that's kind of the point, right? And then the question is, well, how many possibilities are there to rearrange 1 and 2? And for me, this is the left side. Okay, but 1 and 2, maybe there's only one way, so that's why this is the thing. But for a better example, is that, recursively. So now we're asking about this recursively. And for example, this 3 means that 5, 4, and 6 is on the right side, right? Well, how many ways are there to do 5, 4, and 6? Well, 5, 4, and 6 is just any 3 numbers, which is this. So you know that there'll be at least 2 examples. So that's kind of how I did it. Because you basically recursively, so given this is the formula, so I'm just going to go a little bit in the formula. It's a little bit hand wavy. I urge you to kind of figure out the visualization you need. But a lot of this problem is just combinatorics. So if you feel like you need a deeper understanding, I would practice more combinatorial problems, and just kind of think, which, to be frank, to be honest, to be clear, I don't think it's in scope for an interview. It's way too hard to be on an interview, or not way too hard, just requires stuff that I wouldn't expect to be on an interview. But but divide and conquer is a fun thing. So like I think I recommend it in general. But yeah, so basically I I look at the first number, and that's the root, right? And I separate it from the left and the right, and then for the left, how many this is it's similar to dynamic programming, but without the it's similar to dynamic programming in that I have a function that answers a question for me, hence recursion, right? But we don't have to memorize anything because every state is only visited once. So basically, for the numbers that are smaller than it, I ask how many ways are there to count the left or the numbers that are smaller than it, and then I multiply that by the number of ways to count the things that are bigger than it, and then I multiply that by this formula. This stars and bars formula that we talked about, and that's kind of basically it. And I added some mods to do some maths, and it worked out. Because for me, if it worked for this number, it was good enough, and I got it right on the first time, except for off by 1. It's not really an off by 1. It's more that because you don't count the original input as 1, so that's why you would subtract 1 from it. I did have some concerns about this formula and this formula because, and I also, you could notice that I cached the factorials, but I did have some concerns about this formula because I worried that there will be too many digits and this will be a little bit too slow. So if you do this in competitive programming, and some people have this pre-written, but I don't, and maybe I need to figure out how to do it. But basically, what I was going to say is that I would look up something called the modular inverse to solve it in the general case. And if you do something like Code Force, you're probably going to get challenged and it'll probably get time limited. So you definitely want to look at modular inverse so that this formula becomes basically something like instead of this, it is this times the inverse factorial. Or I don't know if it's called inverse factorial, but the modular inverse of the factorial, something like that, right? And that will allow you to mod on. So then, because of that, then now you could do mod on each one, so that the digits don't get that big. But so that's an optimization that I would urge you to kind of read up on, which is modular inverse. But if you haven't got the mathematical background, you would notice that I did a lot of stuff already. There's stuff that's basic combinatorics, meaning like counting the left and counting the right. And there's divide and conquer, which is way computer sciencey. But there's definitely like combinatorical portion and the modular inverse, which is a little bit number theory / whatever. So this is a very tricky problem with a couple of components. So if you don't understand it, or if you didn't get it during the contest, don't feel bad. Definitely read up about these concepts and it'll be okay. So let's go over the complexity, right? So the worst case scenario is if it's basically a linked list, right? Because this is going to start with being a list of size n, and then a recursion will be the size of n-1. And then n-2 with all these like arrays construction. So what that means is that the worst case is going to be n squared, or it's n plus n-1 plus n-2 ... which is n squared, right? I don't know. I think I said it incorrectly the first time, and that's okay because n is 1,000. So I knew that n squared would be fast enough, even with this recursion. And yeah, in terms of space, obviously I have factorial here, that's O of n, but also stack space could be O of n as well. Though you could also depend on how you want to count it, because I have a lot of these things, so kind of n squared, but for n is equal to 1,000, it's okay. Yeah, but you can also obviously do it not that way. But yeah, by just keeping track of indexes or something like that, and in kind of similar to how you would do a merge sort. So you could definitely be more space efficient. But yeah, let me know what you think about this problem. Is like I said, it's really hard. Don't feel bad if you don't get it. There's a lot of maths that you might not know. And these are not maths that you could prove in the moment, or like it's really hard to prove in the moment. So yeah, let me know what you think about this problem, how you solve it, if you solve it another way. Hit the like button, hit the subscribe button, join me in Discord, and now you can watch me solve the contest right about now. This one first. Thousand, huh? a mod as well. I see the recurrence bit. One way. How do you interleave the left and the right of two nodes? That's just, so there's 2 on the left and 2 on the right. That's just factorial over 2 factorial over 2 factorial is 6 and then minus 1. Okay, so then that's just left. Something like that. Okay, I hope this is fast enough. Should be n square. doesn't matter. If what? Unique, then so is the number of ways to times the possible circle left. Is it math.factorial? Probably should cache this, but I just want to get this right. What? Maybe. Oh yeah, -1. So I think I'm right, except for the -1. So that means we have to do some. Okay. Left hand. Just for. This is actually annoying. Maybe I'll leave it. Yeah. Is that a lot of numbers? Yeah, I don't want to deal with the inverse mod right now. We get full. Why is my mentions in doubles though? is this on double? What did I do? Oh, I'm just being dumb. Hey everybody. Yeah, thanks for watching. This was a fun contest, so yeah, let me know what you think. Hit the like button, the subscribe button, and join me on Discord, and I will see you during the next contest. Bye bye.